Moving ahead, this particular shell, cylindrical shell, which is seen here, this is a thickness of delta R for the fluid flowing in the annulus. It is as exactly as a flow through circulatory. But this is in the annulus, but still the shell remains the same. But here we are assuming the flow is in the upward direction. It did not be in the upward also, it can be downward also. But here the consideration is like this. So this is delta R, and the total length of the cylinder is length L, and this is Z direction and R direction. Okay, so you can see this is Z here. Z is equal to 0 and Z is equal to L. Okay, so now in the Z direction, that means in the upward direction, there will be something called phi Z Z. That means we can say rate of Z momentum in, you know, so what do we say? Rate of Z momentum in here, in rate of Z momentum in across the annulus surface at Z is equal to 0. So this is at Z is equal to 0. So what is the first term? What we can write is that rate of Z momentum in across the annulus surface. That means the first one what I can write is that phi ZZ or sorry Z is equal to 0. But when we are saying momentum, but this is flux. Phi is the flux. So this should be multiplied by the area perpendicular to it. So when we are moving upward, what is the area perpendicular to it? So this is as if this is length and delta R. So that should be our not length is the in the direction, right? So what is the area perpendicular? R delta R will be 1, right? Delta R and the see like this. So we are moving like this. So this should be our area perpendicular to this direction. So that means length into delta R. So this should be 2 pi R delta R. Circumference, see here, you can see this total, this should be our, this one. And we are moving in this direction. We are moving in the upward direction, right? So what is the area normal to it? So this particular surface and this particular distance and the circular portion, that is length into breadth. So this multiplied by 2 pi r delta r. Let me write it again so that it will be clear, right? Yeah. So this 2 pi r delta r. This is rate of momentum in, right? So this is what? This is rate of momentum in. So this is in. Now the out, rate of momentum out in the same direction, but leaving at Z is equal to L. So in minus out will be one particular portion in one direction. Right. Now another one is what? Rate of Z momentum across, yeah, will come down. Rate of Z momentum across the shell. Thin shell means across the shell, that means delta R. So our system, what we have taken is like this, and this is the momentum. So this is delta r across this. So what will be our, so this is length will be this length and this portion. I think you are able to get my point. So this is delta r direction. So definitely delta r will not be there. So 2 pi r into length. That is pi r z at r at r, right? And then leaving 2 pi r l pi r z at r plus delta r is what is leaving. So again, rate of jet momentum in across a cylindrical surface. Now we have taken cylindrical surface. But the other one, the external forces, gravity force, in the rate of shell momentum balance, we need to write the moment in the one is external force, but this is what is happening is against the gravitational, which is falling down. That means now actually gravitational force is down, but our flow is upward, so there will be some gravitational force. So what will be that? So 2 pi r total volume, that means total volume is moving, right? 2 pi r delta r into length. So this total volume into density into g. So this volume into density will become what? Volume into density will become mass. Mass into g, that means force. So this is, but this is in the upward direction, but this is minus because gravitational force it is going right. Right. Now let us write the total equation here. Five, oh sorry, let me write it clearly. 2 pi r delta r pi z, sorry, pi z z z is equal to 0 minus 2 pi r delta r pi z z z is equal to L plus pi, sorry, yeah, again 2 pi r L pi r z at r minus 2 pi r L pi r z at r is delta r minus 2 pi r delta r into length into rho into g is equal to 0. So we see that the r into 5 is retained. So what is that we want to say? R into phi z is retained. So what we should do? We should divide by 2 pi 2 pi L delta R. We divide by 2 pi L delta R. So what will happen here is R phi z z that is equal to 0 minus R phi z z that is equal to L plus R phi r z at R minus R phi r z at R plus delta R. This will be totally divided by L. And then this will be totally divided by delta R. So this has been understood. Now minus what is remaining here is R and then rho G is equal to 0. Now you can actually, once I divide this with this term, 2 pi L, 2 pi L into delta cancels, you are left with R here, R into rho. Simple, what is our, we do some manipulation here to get something. So we write this term in the first place, R phi r z at R minus R phi R Z at R plus delta R by delta R plus R phi Z Z at Z is equal to 0 minus R phi Z Z at Z is equal to L by L minus R rho H is equal to 0. What do I do now? We take limit delta tend to 0 in the first term. We retain the first term here and the right hand side. So what will happen is limit delta tend to 0 IRZ Z minus R plus delta R by delta R plus R Z Z Z equal 0 minus, yeah, I can take R here common. Yeah, so here, so we are left with like this. Okay. Oh, sorry. In between, I think I should make it as keep it as minus. Done. Now I just rearrange. So this is limit delta tend to 0. So this by definition, the first term will become dou by dou r r phi. You know, dou by dou r phi r z. Yeah, we have like this. So and the other one, if I take it to other hand, this will become 0 minus phi z z as z is equal to L minus rho g into r. Yes. So this is the equation which we have obtained as of now. So from this place, we can show by the fundamental equation saying that what is phi rz and phi zz. See, phi zz actually is yeah. So up to this place, if you can get up to this place, then we have a definitions of phi zz and phi rz. So with these two equations, we need to again do that. So phi zz becomes phi zz. Actually, this involves pressure term plus, pressure term plus tau zz and plus rho vz, and this phi rz will be tau RZ plus rho VR VZ. Okay. So in this, by these definitions, if you can observe, we have postulated saying that VR is equal to zero. So this term vanishes. Only this term remains in this particular place. And this VZ, this is actually at Z is equal to zero, it will be same. At Z is equal to L, it will be same. And uh, what will happen to tau Z, tau ZZ? Tau ZZ also, it will be the same value. So what will happen is, so we are left with only two terms, right? So now ultimately we have phi ZZ is equal to P plus tau ZZ and plus rho VZ phi RZ is equal to tau RZ. By putting back into the equation, and we can, reduce the equation. So if you keep it back into the R phi RZ, so what will happen to the left hand side? Dou by dou R tau RZ is equal to what is the right hand side? Right hand side is P, at that is equal to 0. See, P plus tau ZZ plus rho VZ, and this all Z is equal to 0 minus P plus tau ZZ plus rho VZ.
Aç kapıyı lütfen.